Hello to everyone, my name is Diego LEÓN and I'll be presenting my first PhD paper. Evolution strategy for deep meta-reinforcement learning based asset allocation. In the field of finance, portfolio management is a fundamental planning problem involving a dynamic sequence of actions to achieve investment goals. The sequential task is a suitable research direction for deep reinforcement learning, giving it property to maximize a reward function in state and action spaces. However, financial markets are dynamic and evolutionary systems. That means that we have data coming in a dynamic sequence and we have changing environments that could lead to different tasks across the time. Deep reinforcement learning approaches are data-greedy systems. That means that we need a lot of data to achieve good trained reinforcement learning agents, while human learners can achieve a good performance with relatively few experience. Also, deep reinforcement learning systems are trained to solve a task at a time and are very sensitive to little changes in the environment. With this in mind, we have to characterize these issues in the problem of portfolio management. But what is portfolio management? Portfolio management involves a task to put some budget to or across a set of available assets to maximize our return and minimize the variance or the volatility of the portfolio. And that's the problem. We need, as you can see in the figure, we need to find the best combination of assets to achieve the best trade-off between return and risk. As you can see in the dotted green line, we have the all possible portfolios with different means, with different returns and volatility, given the perspective of the necessities of the portfolio manager. In this work, we present a novel approach to address these challenges, supported by the development of an evolution strategy for reinforcement learning in a framework called meta-reinforcement learning, based on an evolved population by evolution strategies that generates an informed signal to the reinforcement learning agent to learn fast with fewer data. About the methods and experiments, we need to collect the data to cleaning and a transformation process to put this data in a financial time series dataset. We extract the information from Russell 100 index, and from this index we use 175 assets by 2 months in a minute basis. These assets represents around the 71% of the total capitalization of the entire US equity market. To achieve a better representation, we extract information around about 11 sectors across the US economy. And in the bottom of the left, we have a correlation matrix that is used as the set of the states to the reinforcement learning agent. Also, we have a reward function based on the Sharpe ratio, that is a return by unity of risk. It's a reward function of return balanced across the risk. Well, about the experimental design, we have an evolution strategy solving the task of the portfolio optimization in a searching environment to find the best architecture of the deep neural network and the hyperparameters of the deep neural network and the reinforcement learning agent, so that the latter solve the asset allocation task with an informed signal in a dynamic cycle, finding or extracting a signal from the evolution strategy and giving feedback to the evolution strategy to solve in a cycle, in a dynamic cycle across the time, or to solve the problem of the portfolio management. The experiment results or preliminary results reveals that the proposed strategy outperforms the theory benchmark, the rolling horizon mean variance optimization, and the unique reinforcement learning agent without the informed signal. We have now, at the time, conclusive results because this model requires a huge amount of computational power. But I think that we are in the road, in the right path to find these conclusive results. There are some reference by supporting our work, and thank you so much.